So hello everyone, my name is Dipan Sharma and I'm going to explain the assignment for decision tree learning. So basically we have given the data set in which like we have given the two class play or don't play for a ball game, and we have to decide the play and don't play according to the weather condition. So let's take a look on the first question. At the root node for a decision tree in this domain, what are the information associated with the outlook and humidity attributes? So basically, we have to find out here the information gain for the outlook and humidity attributes. So for humidity attributes, we have to use the threshold 75 for humidity. That means we have to split into the binary. That means one is less than equal to 75 and another one I have to check for greater than 75, and also we have to do the proper computation. So let's check the answer for this question. So I will explain you step by steps. um, so basically, first of all, we can take a review of the data set. So we have given the columns outlook, temperature, humidity, windy, and class. So outlook, we have like three categories for weather. So either it may be sunny weather, overcast, and rainy weather. So basically, temperatures is accordingly. You can clearly see 75, 80 to 75, 68, and 70. So highest temperature you can check from here, like it's something I believe you can check 85 is there and 83. They are like you can also check there are like 65, 81. So they are like, from higher temperatures are there, and there's a variation in the temperature you can clearly see. So according to weather. So like sometime it is also like from like overcast it is 83, but in sunny it is 85 or 80. So we will analyze these things. So in humidity in term you can see the variation like 70, 90, 86, 95, accordingly 96, 70, 80 for any. So for windy, we can exactly understand true, false, and we have the class accordingly. Play, don't play, okay, and then play and don't play, okay. So let's come to the computation part. So basically, uh, first of all, we are going to calculate the entropy. So what is entropy? Entropy basically measures the impurity or the uncertainty in a set of data. For a binary classification problem, here play or don't play, right? The entropy, we will use the formula E equal to minus of P, and then I will say minus of P log P base 2 minus N log N base 2, where P is the proportion of the positive instance play and N is the proportion of the negative instance don't play. So I hope everybody is getting till here. So if someone has doubt, you can ask your doubt till here. So now come to the next point. We can check the total instance. What is the meaning of instance? I will tell you. See, basically the instance is nothing but the total number of weather condition, right? Like, sunny and, overcast and then it's just, you can consider this is what, 5. So let me, show you. So you can consider from here, like this is sunny, like, so basically you can count it. These are 5 and these are how much? 5 and 4, 9, 9 and again 9 and again it is what? 5, right? So it is total 14, right? So so these are the total instance, right? So in this total instance, how many you have sunny? That is 5. Overcast is 4 and rainy is 5. Okay. So now let's go ahead. Okay. So if I will go ahead, I can clearly see that total instance is 40 and play instance is 9. Again, we can count it from the class. So and don't play instances, don't play is 5. You can clearly count it from here in a similar fashion. You can check it. So you can count the number of play from here, right? So see, so this is one play. One is here, 2, 3, 4, 5, 6, 7, 8, and 9, right? There are 9 plays, and don't play is of course 14 minus 9. That is 5, right? You can check 1, 2, 3, 4, and 5. I hope till here everybody is getting. I hope it makes sense, right? So now the main point is that, now we are coming to the main point. So the main point is that here we got the plain states and don't play states we got, and then we can find the positive proportions and negative proportions. So this is going to be 9 by 14 and 5 by 14. That means we can get the value of E, that is nothing but 0.4940. So we can, after that, we can calculate the information gain for outlook attribute, right? So how to calculate the information gain? That is a very interesting question here. So we can split into the three term to the outlook, right? Three weather according to weather. So basically, one is sunny, one is overcast, and one is rain, right? So in you can clearly check, as I told you, the instant and sunny is 5. Play we have 2 and don't play is 3. You can see from the table, right? So for sunny you can check it. Play is 1, right? Right. And how many play? Player 2 and don't player 3. So similarly we can check for others as well. Right. So how much you will get the value? Let's check. So when you will plug in the value E of sunny equal to what you will get. Like you can plug in the value 2 by 5 is a proportion, because 2 is a play and 5 is a total instance. So 2 by 5, and negative for similarly 3 by 5. So I will just make use of the formula as I told you, and then I will plug in the value here. That is going to be 0.971. Then I will split it by overcast. That means instance is 4, play is 4, and don't play is 0. You can check it clearly from the table. So we can calculate the entropy similarly. So we are getting E overcast equal to 0. Similarly, we can get the split by RAN. That means play equal to 3, don't play is 2. So we can calculate the entropy after splitting the RAN. So we can get 0.971. Now we will calculate the information gain by computing the weight average weight entropy. Because we have split it by outlook, right? So what is the formula we will use? E root minus of 5 by 14 dot E sunny plus 4 by 14 dot E for overcast plus 5 by 14 into E ran. So I am multiplying this 5 by 14, right? So I am multiplying. The basic reason is that here you can see in this sunny one, we have total 5, right? Total 5 instances, and we are considering over 14, right? So that means the sunny instance for the sunny is 5 basically, right? So what is the total outcome will be 5 upon 14, right? Because only 5 we have to choose over the 14 one. So for sunny, what will be the how to calculate the weight average entropy? For that, we need to multiply by 5 by 14 into E dot sunny. Similarly, total 4 is there for overcast according to the data set, right? Over the 14 instances. So 4 instances for uh, 4 instances you can consider for overcast, right? Similarly, 5 for man, and you can consider 5 by 14, and you can calculate this value. E root, that means entropy of node we have already found out, right? That is nothing but 0.940. After that, we are getting the value 0.246. And then what we are doing, okay, this is done. Okay, so now I'm coming to the next point. We can get the information gain for humidity attribute, and here is we have the restriction that humidity should be either less than equal to 75 or humidity is greater than 75. That means clearly you can consider that humidity is less than equal to 75 means we can consider that humidity is low, and like here if we consider greater than 35, that means humidity is high. So if you're considering less than 75, you can again check. Instance is 5, play is 3, and don't play is 2. Again, now you can ask the question, sir, why, how are you getting this 5? Okay, so I will again go to the table and I will show you how less than equal to 75 is 5. Okay, so this is the question now. Okay, so let me solve this question. See, if I will check here very clearly. So this is less than 75. Okay, this is less than 75. This is less than 75. Okay, this is equal to 75. This you will also consider. This will less than 75. So how many it is? 1, 2, 3, 4, 5. Are you getting this point? So these are less than equal to 75. Okay. If you are considering greater than 75, that means these are the greater than 75, right? 1, 2, 3, 4, 5, right? 6, 7, 8, and 9, right? These are the greater than 75, right? So I hope everybody is getting clear. So basically what is going to be happen in this scenario? This is going to be 0.971. Okay, and then so okay, please give me a moment. Yeah, So here we have calculated it, right? So here we were, right? Here are we. So see, so humidity split by humidity less than equal to 75 is 5, as we have counted from the data set, right? And then 3 and 2. Play and don't play, you can similarly count it from the, like, from the given data set, from the class one, right? So now you can find the value. This is again 3 by 5 is the total number of play, and then total instance 5, 3 by 5. So again, I'm using the entropy formula basically. So log 3 by 5 base 2 plus 2 by 5 log 2 by 5. So do you know this 2 by 5? I told you the formula P log 2 log P base 2 plus n log n base 2. So by that formula, I'm using it, right? Similarly, I can calculate the value for greater than 75. That is nothing but 0.918. Similarly, because play is 6, don't play is 3. Again, 6 by 9 is P and n is 3 by 9. So you can plug in the value here 0.918, and then you can compute it. So after that, again, I will compute the weight average entropy after splitting by humidity. So I will get the information again for humidity. That means E root minus 5 by 14 entropy of humidity low plus 9 by 14 humidity high. Why I'm doing 5 by 14 here? Because I told you that how many humidity lows are here, that is 5. That means less than equal to 75, and this is greater than 75. So after doing this, I'm getting the value 0.02. Okay. So what is the, now what is the explanation about it? So we can say outlook has a higher information gain 0.246 compared to humidity 0.002, indicating that outlook is a better attribute to split the data at the root node of a decision tree in this domain, right? Because information gain is very high for outlook. So this means outlook provides more discriminatory power in the separating the class. Of course, in play and don't play, so you can go ahead with outlook compared to humidity. So this this concludes the computation of information gain for the outlook and humidity attributes at the root node of the decision tree. I hope everybody is clear here, right? So which one is a higher information gain? Outlook, right? So of course, like if you have to split, you will go ahead with the outlook, right? To split the data, right? To at the root node. So I hope everybody is getting till here, no doubt at all till here, right? We can go ahead. So now what is the next question? Again, at the root node, what are the gain ratio associated with the outlook and humidity attributes using the same threshold as in a this CO to show your computation? Okay. So see, in this question again, we have to find out the gain ratio. Okay. So let's from like outlook to humidity. So we can see the table once again, the data set. So here again the same things, and now let's calculate the gain ratio. So total instance is the number of total instance is basically 14. We have already seen an entropy of the root node, that is 0.940. We have already calculated. So step by step computation, we can see like computed split information basically is split information measures the intrinsic information of an attribute. It is calculated as the entropy of the distribution of the instance among the different branches of an attribute. So what is the split information? Basically it measures the intrinsic information of an attribute, right? So how will be calculated? We have to calculate. So what we will do, we will just calculate entropy value, entropy distribution, and then I will take all the instances among the different branches of an attribute, and I will sum it. So I will show you from by the calculation. So see what we are doing here is split information outlook we are taking, and we are taking for this is for what? Sunny. This is again for overcast, and this is for rain, right? So after that, like you can get the split info, that is 1.77, right? So again, like this is in split information, you have to be very careful. Here we are considering, here we are not taking any like in above scenario we were taking entropy, but here we are directly taking log of 2 5 by 14. That means we are considering the uh, total instances here, right? Here we are not interested to know in play or don't play. We are taking whole value here, like we are taking the whole value, because 4 is your scenario where you finding that 4 is a number of play, right? Because you can check it in split information for Sunny. You can see how many scenarios are there. They see play, don't play, don't play, don't play, play, right? So all the 5 scenarios are there over 14. So that's why I'm multiplying here while I'm calculating the split information, and then I will take the log 5 by 14 base 2. I will calculate the value. Similar point I will do for humidity. So in humidity, what is happening? Check it. For humidity, what is happening? You are taking 5 by 14 log 5 by 14 base 2 plus 9 by 14 9 by 14 base 2. Because why is the problem is here that you have to consider only more than 75 and 75. So there will be two class because it's a binary one, right? So you will only one class that is 5 and another class you will take that is 9. Because 9 plus 5 is 14 here, and 5 is means 5 instance, that means less than equal to 75. 9 means those instances which is greater than equal to 75, right? So you can calculate this value, you can get 0.940. Now I will come to the main point, that is compute gain ratio. Basically, I'm trying to compute the gain ratio. So how can I calculate this? So calculate the gain ratio, you need to divide the information gain and split information, right? For the outlook, right? So you will divide it and you can clearly see 0.2046 and 1.577, that means 0.156. And you can get gain ratio for humidity, that means 0.002 we have already calculated, and 0.940 we have already calculated. We can divide it and we can get 0.002. Okay, so gain ratio for outlook is how much? 0.156. And then gain ratio for humidity is 0.02. So gain ratio confirms that outlook is a better attribute to split on a compared to humidity, right? Because the gain ratio for outlook is very high at the root node of the decision tree, right? In this domain, right? So we can consider like the outlook gain ratio is much far like it's more because it's 0.156. Right. So of course, like you can see, if you have to go ahead with the outlook, of course you will go ahead with the outlook because it can contain the, you can make a branches, or like you can divide into the attributes easily because it's a high gain, it's a high gain ratios, right? Right. So you can see this complexity introduced by the number of branches each attribute creates, right? So this adjustment takes into the account, right? So what we are trying to do here. So now, with the help of this scenario, while getting the higher value and low value here, 0.02, we will be able to draw the decision tree, right? So let's see this, the next question. Okay, so we can see the next question. What will be the next question? Draw the complete unpure decision tree showing the information gain at each non-leaf node and the class prediction at the leaf. Let's go through the data set. Okay, so what is going to be seen? So let's draw the complete unpure decision tree information gain calculation I can apply. So I will calculate the entropy for the data set, that is we already know 0.940. Again, I will calculate the information gain for outlook. That means it is, please give me a moment. Yeah, so you can calculate the, so information gain for outlook, sunny subsets. You can calculate the entropy for sunny, you will get 0.971. And you can calculate the overcast subset, that is nothing but 0. Because there's no don't, there's, we know the play, we have the only play, we don't have any don't play, right? So that's why. Okay, we can similarly, we can calculate the value of range subset. That means again, we will calculate the same thing. We have already calculated it, right? So we can get the information gain contributions for over subset information gain is 0. And again, like for some sunny subset we have calculated, which is nothing but 0.246, right? So in this scenario, what is happening? So information gain we calculated, right? After that, what we can, according to this, let's draw the complete decision tree. So we have the two scenarios. From the outlook side, we will break the attributes because you know that the gain ratio for outlook is very high, right? So if you will take like, you know, sunny, we have the two situation here, humidity and less than equal to 75. So we are getting play. If you will say humidity greater than 75, that is don't play. For overcast play, because we don't have any scenario for don't play, that is 0, right? So here is two scenario. For windy true, it is don't play, and for windy false, it will be play. So we are able to decide it. So let's explain it properly. See, outlook is chosen as the root node because it provides the highest information gain, right? Effectively separating the data into the classes. Again, sunny branches I have to consider. So if outlook is sunny, further split based on humidity, that means information gain is 0.02. That means we can clearly say if humidity less than equal to 75%, predict play. Okay, and if I will say humidity is greater than 75%, predict don't play. Similarly, for overcast branch, if the outlook is overcast, predict play directly because all instances under this condition belong to the play class. Okay. If outlook is ran, further split based on windy, because information gain we already find out that is nothing but 0.971. So if it is windy, we can say windy equal to true, predict don't play. And if it is not windy, that means windy equal to false. So predict, play, right? So this structure outline the decision tree with the information gain values at each split and class prediction at the leaves. So with the help of that, we are able to we are able to understand the tree segment, right, for the data set, right, for the different attributes and then associated information gains. So, like we can come to the conclusion. Information gain calculation as follows. So, sunny subset gains we got 0.246, overcast subset information gain calculation we got 0, and random subset 0.349. So, this calculation confirms that information gain value provided initially. Okay. So, with the help of that, we are able to draw the decision tree structure, right? Now, coming to the next question. Uh, this, so I hope everybody is getting clear. Any confusion, any doubt, or any sort of doubt in structure or calculations, you can definitely let me know. Because it's all about the calculations and checking with the data set, and then we are able to identify and drawing it. So basically, completely fine if we can ask your doubts. I will be ready to help you. So describe about the OP feature. So OPS is basically the object-oriented programming feature. What is this? Let's consider about the object. So everything is treated as an object. An object is an instance of a class which encapsulate attribute and behavior like methods. For example, you can consider a car. Car is an object because it has attribute like color, models, right? And the methods like you can say accelerate and brake. So that is a method, right? If you're considering about the initialization method is basically used to initialize the object attributes, because so this basically helps to put the object into the initial state, right, when it is created. What is the construction here? So construction is like such a construction for the class preparing the object for the use. And self, it is a convention in a Python to use self as the first parameter of the instance method, right? It refers to the instance of the class itself, right? Okay, so I hope everybody is getting right. So basically, for initializing purpose and for giving, as a first parameter, you are putting the self, right, to point out, right, your parameters at the initial level. And then, like, you can come to the classes. Classes is basically the blueprint for getting object. It's define the attribute and method that object of the that class will have. So here's a simple example of class in a Python I have taken. So we can define the class, and always remember when you define the class, it's always you should define by the capital letter C, and you will define the initial function, self, color, and model. So basically, these are the parameters. So I will initialize it color equal to color, model equal to model, speed equal to 0, because we don't have such parameters. Accelerator we can take self comma amount. So either you can increase the accelerator or decrease the accelerator, right? So if you will increase the accelerator, this is going to be decreasing the speed, and you can increase it as well. So minus equal to you can say no, right? If you are coming to the display speed, that means again we can check the speed is nothing but kilometer per hour. So we can check its speed by taking the color and model, right? Is moving at what speed you can clearly display. Now come to the most important point, encapsulation part. So I just want to introduce here a little bit here. So encapsulation is the bundling of data attributes and methods function that operate on the data into the single unit, that is class. So it's hide the internal state of an object from the outside world and only exposes the necessary part. This promotes the modularity and code organization. So basically what is happening in this, you don't want to, so you want to keep some privacy. You want to only show, the methods you want to only show, which we are preferring, right? Like basically in bank sector, we can't show to the, account number to the customer. So of course, encapsulation is required. There are many things that you need to keep privacy. So yes, that's why these kinds of things is important to understand that what kinds of method we have to be put into the public and private. So coming to the inheritance basically allows a new class, subclass to inheritance attribute and a method from the existing class superclass. So it supports the code reuse and promote hierarchy classification. For example, you can say car class I have defined. Right now, what I will define the new class that is a inherit coming putting carrying the characteristic from its car class. So basically electric car is basically what is happening. In this we have the initialization function, cell curve model and battery capacity. So we are redefining it, like we are taking a one new parameter, it's called battery capacity. But you are coming to the car class, here we are not taking, you can see you have just taken model. So we are just, of course, like one new things, one new features we are adding it, that is battery capacity, right? So if you're taking the battery capacity here, and then you can initialize this color comma model as a super class, it is I supposed to be, because why I'm taking from super class, because super class is your parent class. So basically these things we are calling from the car class, right? And then you can initialize it battery capacity, because this is the only new parameter is generating here, right? So we can take display battery capacity, and then we can take as a battery capacity of what. So because car and model is already defined, right, in your parent class, right? So this is the subclass basically, and so existing class is called the superclass, right? I think everybody is getting my point, right? So the car class is a superclass, right? And the new class that you are defining is subclass. So polymorphism means that object of different classes can be treated as object of a common superclass, right? Basically, it is how the method to be written that can work with object of various type and class. For example, I will say both car and electric car can respond to a display speed method, right? So display speed method can work with the both kinds of class, with the car and electric car as well, right? So these are the method which is will be commonly used, because electric car and car has a one common thing, that is the speed. So speed is a one common thing, right? So it can be one of the, you can consider like a method that is used by both the class, right? And it's displaying this speed, uh, you know according to their according to our choice, or according to, it depends on what kinds of model it is. So of course it should show the speed properly, right? So what is happening in this situation, that polymorphism, basically we have the different classes, right? But what we want to do here, basically what we want to do, we want to put any objects which is common to both, right? And can we can just, after, like we are using the, we are modifying the classes again, like we are saying, so subclass, right? So in that we have also the speed, because in electric car you can consider the speed is there, in a car itself the speed is there, right? So I hope everybody is getting this point, right? Yes, right. So basically here object can work with the same, with the both class, right? Any doubt till here, so you can please let me know. So I've just taken a little bit here about polymorphism. We can take examples also to understand this. So similarly I can take abstraction. So abstractions involve the focusing on essential qualities of an object rather than its specific details. So it simplify the complex system by modeling the classes appropriate to the problem domain without needing to know internal implementation details. So basically abstraction why required, because we want to understand the qualities of object, what can be the characteristic of the object, and we are not interested to know the specific details why this kinds of object is like specifically said, or like why it is like color, and like anything specific details you can consider. But the main concern is that you need to understand the qualities of the object, right? What are the quality, like if we consider the so feature software can be structured and modular and easier to maintain and extend, right? So I hope everybody is getting till here. If any doubt, you can please let me know. So I hope I am done. Thank you very much for your time.